Hello everyone, grab a drink and join me tonight as we run down the entire press presentation, all the slides for the Intel Core Ultra Processor 200S series. This is a new generation of processors coming to the desktop from Intel. This is the announcement today, not the official launch. The launch will be a bit later this month in October. I want to run through each of the slides as quickly as possible and show you what Intel has to say and talk about each one. We've got about 47 slides to go through. This is going to be a very quick run through today. I'm going to try to get through this as quickly as possible. If you want to check our website at www.thefpsreview.com, we have a written article where we also show all of these slides, talk about each slide, discuss that, and in the summary, I have a thoughts and opinions section where I give a more detailed thoughts and opinions. So you're welcome to go read that and check that out for more of my thoughts on this new generation. As you can see here, Intel is introducing the Core Ultra Processor 200S series. So what does that mean? Well, technically, this would be 15th generation. However, Intel is not calling it 15th generation, even though if you look at it logically and chronologically, this is Arrow Lake or Arrow Lake S, the desktop variant. And if you look at that compared to the previous generation, that was Raptor Lake-R, which is Raptor Lake Refresh. That was the 14th generation. Before that was Raptor Lake S, which was the 13th generation. Before that, Alder Lake S, which was the 12th generation. So chronologically, this is a 15th generation, but you won't see Intel calling it that. It will now be called Intel Core Ultra Processors, and you will see this Core Ultra naming quite a bit. You're still going to get the 9, 7, and 5 series. However, the numbering after that is going to be different. So they're dropping the i7, i5, i9, and instead going with the Core Ultra in front of the 975, and then a 3-digit number after that. And then these are the K SKUs that remains. There will also be KF SKUs without integrated graphics. So we are going to have to get used to this naming a little bit. But the entire thing will be called Intel Core Ultra, and then 9, and then 285K, and that's going to be the top part. We'll talk more about that as we go through and discuss the different SKUs that are available. But as I mentioned, today it is all about an announcement. The actual launch and sales of these CPUs is not until October 24th. So keep that in mind. This is just an info dump pretty much on the series for everybody, and then all of that will be available on the 24th, and that is also when you will see reviews. And we will have reviews on these as well, so make sure to check out our website for that for day one reviews. Moving on, I'm showing these a little bit out of order. I first wanted to touch on the series, all of the SKUs that are being shown, and the pricing. I wanted to hit that first in this video before we jump into architecture and that sort of thing. So at the top, we have the Intel Core Ultra 9 285K. So now you can see how that new naming works. It's Intel, and then Core Ultra 9, and then Core Ultra 7, and then Core Ultra 5. And then after that is the 285K, the top SKU, 265K, and then 245K. So that's going to take a little bit of getting used to, especially the 245K, 265K, 285K. We are going to have to get used to that, but you may see these referred to as Core Ultra 9, Core Ultra 7, and you may also just see people calling these the 285K or 265K or 245K, and you just have to remember, is that a Core Ultra 5, a Core Ultra 7, or Core Ultra 9? Starting at the top, Intel Core Ultra 9 285K, top SKU $589. Now this is the suggested retail price. The actual pricing in retail could end up being a little bit different. This is not necessarily what you will see them for on sale, but this is the suggested pricing. So again, we will just have to see how that actually turns out, but $589 is what Intel is saying, which is honestly a good price if you compare that to, let's say, the 9950K, which is, which is actually a good price if, say, you compare that to the 9950X from AMD, which is more expensive by MSRP. Of course, street pricing is what matters most, and we'll talk a little bit more about that at the end. So the big thing that you need to understand when you read these is that Intel's hyperthreading, SMT, is no longer supported. That's right, with Arrow Lake, the Intel Core Ultra 200S series, hyperthreading, SMT, is gone. That means your actual thread count is only what your total core count is. However many cores you have, that's how many threads you have. So if you look at it in comparison to the previous generation Raptor Lake Refresh or Raptor Lake, then it's going to look like they have less threads because they do. But therefore, more has to be made up in way of IPC and performance to make up for that loss in multi-threaded situations. Obviously, for single-threaded, that wouldn't matter. So the top one has 24 total cores. How that's divided is 8 P cores, 16 E cores. Intel is still keeping with the hybrid P cores and efficient cores. That remains. So because of that, 8 plus 16, we have 24 total threads. This also does have integrated graphics. So it is the Z or She graphics, and that is 4 GPU cores, and that is the same on all of these SKUs. So the integrated graphics is the same integrated graphics across all of them. The speed varies a little on the lowest model. These also have an integrated NPU. Each one has an integrated NPU. This is basically the same NPU from Meteor Lake. 13 TOPS is what they have. But Intel can claim, rightly so, that this is the first desktop CPU with a built-in NPU in this high-performance class, like a 285K. It is, however, a 13 TOPS NPU based on the one from Meteor Lake. The max frequency on the 285K is 5.7 gigahertz. Under that, we have the Intel Core Ultra 7 265K. Now, this is a 20-core, 20-thread part. So that is 8 P cores, 12 E cores. So we get rid of a few E cores there. Still 4 GPU cores, 13 TOPS NPU, and its max frequency is 5.5 gigahertz. This one is 394. Then under that, we do have a KF SKU, and that just simply takes away the integrated graphics. That is 379. Otherwise, it's the same hardware as the 265. Under that, we have the Core Ultra 5 245K. That is a 14-core, 14-thread part. 6 P cores, 8 E cores. Still 4 GPU cores, 13 TOPS NPU, 5.2 gigahertz frequency, and 309. Then we have the Intel Core Ultra 5 245KF. Same thing as the 245, just lacks the integrated graphics, and that is 294. So from the bottom to the top, 294 up to 589 for the highest end SKU there. So that is the Ultra 9, the Ultra 7, the Ultra 5. Will there be more in the future? Absolutely. This is just the start of this generation. We don't know what other parts specifically or when those will be announced, but we can imagine there might be other SKUs in there in the future. This is a look at the entire details of these new CPUs. So this gives you a better idea of what's going on here, and this is the slide that I'll spend a little bit more time on, and the other ones will probably be a little bit quicker, because this is really the meat of what you are probably interested in. So let's talk about all of this. The 285K, top end, as we said, 8 P cores, 16 E cores, 24 threads because it's 24 cores. It has an L3, which Intel calls its Intel Smart Cache, an L3 cache size of 36 megabytes, an L2 cache size of 40 megabytes. And then we have many different boosting frequency technologies supported. You will notice it has the Intel Thermal Velocity Boost and Intel Turbo Boost Max Technology 3.0. And then the P cores also have a max turbo frequency, and the E cores have a max turbo frequency, and then all of that has a base frequency as well. So there's a lot of frequencies in there. And what this simply means is some of these things like the thermal velocity boost and turbo boost are reliant on the temperature of the CPU and also for how long it is sustaining that clock speed. Some of these are only very, very short-lived clock speeds that it can burst to very quickly and then it falls back down. So the thermal velocity boost is up to 5.7, but that's not something that you are probably going to see sustained for a long period of time. That's going to be a short burst scenario, 5.7. Then the turbo boost frequency is 5.6. However, the P-Core max turbo frequency is 5.5, and the E-Core max turbo frequency is 4.6. So it will be interesting to see how all of this works in actual applications and games, and I think it's going to vary a lot on the application and game. The type of workload is going to depend and show you what kind of frequency you're going to get. So if you have, certain workloads that are just hitting all the cores really hard, it's going to be a lower frequency, obviously, and that's going to be different than if you're playing a game and only using a few cores. So these frequencies will vary quite a bit, but it has a range up to about 5.6, 5.7, and then it does have base frequencies as well. So that is the 285K's frequency. As you can see, we have the SKUs cores, Intel graphics. This is the ARC-based graphics, GPU max frequency of 2 gigahertz, GPU base frequency of 300. And you'll see that that's common on everything except for the 245K, which just bumps that down to 1.9 gigahertz. So it's the same integrated graphics throughout the entire thing on the K SKUs, except the 245K just drops the frequency a little bit there, and not even by a large amount, just a very small amount. But they all have the 4 cores. And as I mentioned, they all have NPUs, and this is a huge feature from Intel that they are putting forth. Now, this is, as I said, the Meteor Lake NPU, not a newer NPU. This is based on their NPU Gen 3, their Gen 3 or NPU 3. 13 TOPS is what you're going to get out of that. So looking at the lanes, the CPUs support 24 lanes. So that's solid across all the CPU SKUs here. The maximum JEDEC DRAM speed has changed. It is now DDR5 6400. That is only with 1 DIMM per channel or 1 DPC. That is 6400. If it's 2 DPC, that is going to be 5600, not 64. 2 memory channels, 192 gigabyte maximum memory capacity. Now, here's where the fun starts, the power. So the processor base power is 125 watts across all the CPUs, but as we know, that's not what you're actually going to get, and that's not what the motherboards are configured to run at out of the box. So the maximum turbo power on the 285K is 250 watts. And we double-checked with Intel, but that means PL1 and PL2 will be locked at 250. And that will be the same on the 265 as well, 250 watts. So PL1, PL2, 250. We also have a few Intel features here: reliability, availability, and serviceability, Intel SIPP, Intel vPro, and Intel ISM. So that is supported on the 285K and 265K, and you'll see the KF SKUs kind of drop some of those features. Now let's talk about the 265K, the Ultra 7, the 20-core part, again, 20 threads, 30 megabytes of the L3 cache, 36 of the L2 cache. This one drops the Intel thermal velocity boost frequency, so it is not capable of that extra little boost. So therefore, it has a turbo boost max technology frequency of 5.5. Then you have a P-Core max of 5.4, P-Core base 3.9, E-Core max 4.6, E-Core base 3.3. That's the 265K, and the 265KF is the same. Again, on the 265K, you have the Intel graphics, 4 cores, 2 gigahertz max frequency, and then the KF drops that, and everything else is the same as the 285K. So the same memory support, same NPU, same features except for the KF. Also 250 watts. 265K will be PL1, PL2, 250 watts. Then at the bottom, you have the 245K. That is the 14 core, 14 thread part. 24 megabytes of L3, 26 megabytes of L2. This one drops the thermal velocity boost and the Turbo Boost Max technology to get all together, and therefore only runs at the P-Core Max turbo frequency of 5.2 and the E-Core Max turbo frequency of 4.6. So you lose the turbo boost and the thermal velocity, and you're just running at the max P-Core frequency on those. It again also has the Intel graphics, 4 cores, 1.9 gigahertz, so it drops the speed just a little bit on the GPU, but not a lot. The PCIe lane configuration, memory configuration, and even features are all the same, again, except for the KF part. Now on this one, it is a 159 watt maximum turbo power, and you'll see that's very close to that 125 watt processor base. Now again, keep in mind that these power limits are not necessarily what you're going to see in actual, real world scenarios, especially on the Ultra 5. I think with the 265K and 285K locked at 250, that's probably where it will end up being locked at, and that's what you will see out of the processor. But with the Ultra 5, it could be more than 159 watts in actual power usage, so we will have to, test that to find out. But that is what Intel is quoting, maximum turbo power at 159 there. All right, now that we have looked at all the SKUs and what is coming, we need to keep in mind that all of this is also based on a new socket LGA 1851. That means you will need new motherboards for these CPUs. You cannot use existing motherboards. These are on a completely different socket and are not compatible with anything below it. So you will need an LGA 1851 motherboard, and we'll talk about that when we get to the chipset section here, because there's also a new chipset attached to this because of the new socket. So keep that in mind. You are looking at not just a processor upgrade here, but also a motherboard upgrade for this generation. Okay, I am now going to go over all of the slides that talk a lot about the architecture and that sort of thing, but I'm going to go through this pretty quickly. A lot of this you probably saw during the Lunar Lake explanations. We also have a video on this channel about Lunar Lake. If you saw any of the Lunar Lake information, a lot of that's going to look very similar because the P cores and E cores are based on the same Lunar Lake cores. So because of that, this is all going to be redundant. You've seen it before if you've heard about Lunar Lake. Now that's as far as the compute tile goes. If we talk about the graphics tile or the NPU, that's related to Meteor Lake. So you would want to go back to Meteor Lake information to learn more about the graphics cores and the NPU. So we'll touch on it today a little bit here, but let's just quickly go through this. So the big thing you're going to hear about, and you are definitely have heard by now, is the performance per watt savings with Arrow Lake. Intel's goal was to reduce power. Flat out, that was the goal. Performance per watt, reduce package power by 40%, deliver 15% generational multi-thread performance while maintaining game performance. Expand AI acceleration, integrate the latest SKU graphics for the latest media support, reduce the package temps 10 degrees or so while gaming. Everyone knows Raptor Lake was power hungry, and Arrow Lake's intent is to fix the power hungry and hot nature. But what does that mean for performance? Well, you're going to be a little surprised by that. All right, Arrow Lake, the cooler and more efficient gaming CPU. Same performance. This is what I was saying. This is the surprising part. Same performance at half the power of Raptor Lake R. Remember, Raptor Lake R is Raptor Lake Refresh, which is the 14th gen right before this one. So think 14900K. If you want to compare 285K, they're talking about the 14900K here. Basically, Intel is saying Arrow Lake will have the same performance as Raptor Lake Refresh, 14900K, but at half the power. So that sets expectations already. They are saying really not a huge generational performance uplift. So let's keep reading. Skymont, Lion Cove, and Favreau's team up for impressive performance watts gains. Highest multi-thread performance up to 24 cores for industry-leading compute throughput on desktop PCs. Feature-rich enthusiast experience. XE LPG for new codecs. Around 36 tops for desktop AI PC. Now, That 36 tops is every tile combined on the CPU. This is the compute tile, the graphics tile, the NPU combined. So keep that in mind. Integrated Thunderbolt 4. Okay, let's talk specifically about the P cores and E cores. As I said, if you're familiar with Lunar Lake and have seen those presentations, then this is going to be extremely redundant for you because it's the same P and E cores. So for the P core, it's using Lion Cove. That is versus Raptor Cove that was on the previous generation Raptor Lake. So that's the P core. So what does that provide? Well, that's about a 9% IPC uplift over Raptor Cove. So Lion Cove, about a 9% IPC uplift. That's the P core. Then you have the E core, Skymont. These new Skymont cores are versus the Gracemont E cores on the previous Raptor Lake CPUs. This is where we see a much bigger gain. The E cores have a 32% IPC uplift over the previous gen. From this, we can see huge uplift E cores, not as huge P cores. P cores, progression, yes, but not as much as E cores. So the E cores are really the showstopper here for this generation. Now, even though you're getting this IPC uplift, the power is going to be greatly reduced. Remember, as I said in the previous slide, half. It's going to be cut in half, somewhat around that. So that's really the advantage here. Now, because of this IPC uplift, we're still going to get similar performance. And why is it similar and not faster performance? Remember, IPC is not performance. So why is it similar performance of Raptor Lake and not faster? Well, remember, hyperthreading is gone, so that you don't have that anymore, right? So for multi-threaded applications, you don't have the advantage of, way more threads. You just have however many there are here, 24 threads. So you have that. And then you also have a reduced clock speed. The clock speed is overall lower on Arrow Lake than it is on Raptor Lake. So you have those things that are lower, but then you have this IPC, which is higher. And all that pretty much does is it evens it out. It brings everything back to parity, pretty much. And that's why it's the same performance, but at half the power. So let's look on here. So some of the things you can see here, up to 36 megabytes shared LLC on the P cores, 2 times cache bandwidth on the E cores. Deeper queuing, these are wider units here, enhanced prediction, wider allocation and retire, wider scheduling, and you'll see all that a lot. This is a much wider CPU pipeline overall compared to Raptor Lake. So this is the cache layout. And as we mentioned, the L3 cache, Intel calls it Smart Cache. It is able to have more cache and also more shared cache. And you can read this all you like and study this for as long as you like, but just remember it's more cache and it's more shared cache and also more cache bandwidth as well. Now, this is the new GPU, but it's not really new. This is what we saw in Meteor Lake. So this does not have the XMX engines that you find in the discrete graphics cards. This has DP4A, but it does not have the XMX. So it does not have that hardware, those hardware accelerating units. It just has DP4A, and that's what it uses. But it still supports, it's got 4 ray tracing units. It's got 4, each CPU is going to have 4 cores. And it's based on the Intel Arc software stack. 8 tops total out of this integrated chip. And then the important part really for the inclusion of these integrated graphics is going to be the media engine for the encode decode. That's going to give you the Intel Quick Sync and all the codec support for encoding and decoding the different codecs. And that's really the benefit here with this integrated graphics is you get that media engine, which is very powerful for many, many creators. Intel Quick Sync has actually been really, really good, and creators do use that. So that's very useful. So that's on there for that. Unless you get the KF parts, then they don't have the integrated graphics. All right, and then we have, of course, the NPU, and you can see here how Intel is calculating and combining everything. It's saying up to 36 platform tops, but that's combined. That's the GPU is 8 tops NPU 13, and the CPU is 15. Interestingly, the CPU or compute tile is more TOPS than the NPU. But if you combine it all, 36. And then if you combine that with a discrete GPU, that's obviously going to be magnitudes more. And since this is on a desktop, you're probably going to have a dedicated GPU more often than not. However, keep in mind that these can also be used in business computers that maybe do not have discrete GPUs. A business computer may rely only on the integrated graphics and not need a discrete GPU. So in that scenario, you now have access to an NPU that you would not have had otherwise because you have no discrete GPU. So you can look at that as an advantage in like a business scenario or as a business computer that has a CPU such as this, but does not have a discrete GPU. The NPU could come in handy for some lightly AI accelerated tasks that you use in your business. So that is something to keep in mind and could be useful for people that need it for that. This is how everything is laid out. We start with the package, and this is an Intel package. We have the base tile that everything is laid on. You can see that this is the traditional tile system we're all used to now from Intel. You've got the compute tile, the I/O tile, the SoC tile, the GPU tile, and the filler tile just to fill in some space there. And all of that sits on top of the base tile. And so each one is its own little separate thing. The compute tile is pretty much Lunar Lake. You know, think of that as very similar to what Lunar Lake's compute tile is, except on a different manufacturing process. This is actually done by Intel, not TSMC. So that is a difference from Lunar Lake, but it's the same cores, just on an Intel fabrication. And then you have the GPU tile and the NPU, which is basically from Meteor Lake. And then you have everything else going in there. And that's all put together. The IHS sits on top. And we were told that the hotspot is a little bit different on these new CPUs. The exact center hotspot will be shifted a little bit on this. I think it's going to be shifted a little bit to the north. But don't quote me on that just yet. But it is somewhere different. I know that. It is a different hotspot. However, that said, current LGA 1700 AIOs and coolers should be compatible with this. You will, however, may see some designs where different offset brackets are perhaps provided to give better positioning for the hotspot. So check with your manufacturer of your AIO, but the LGA 1700 brackets and mounting should work on that, should be compatible with LGA 1851. But do check with your vendor manufacturer for your AIO or cooler and make sure of that compatibility before. All right, so again, this is just a quick summary of the specifications which we've been through here. 24 cores and threads on the 285K, 8 of them are P cores, 16 are E. 20 threads or cores on the 265K, 8 of them are P cores, 12 are E, and then 14 cores, threads on the 245K, 6 P cores, 8 E cores. All of them have the same GPU cores. All of them have the same NPU at 13 TOPS, and then they go from 5.2 gigahertz up to 5.7 for your maximum boost on your fastest CPU there. All right, let's talk a little bit about how they have reduced power here and what that actually looks like. Intel is stating here, as we saw before, that Arrow Lake halves productivity power, up to 58% lower package power and lightly threaded work compared to Raptor Lake R. That's refresh. So the 58% is one scenario in a Zoom video call. Remember, it does say here in a lightly threaded. So in lightly threaded work, you'll see a bigger impact on the power savings versus Raptor Lake refresh. But that does seem to be the outlier in their own chart. We have 3 things here that are showing a between 42 and 44% reduction. So not quite 50% here. And that is the majority of what we see on this particular chart. So keep that in mind. This is an up to 58, but maybe in specific lightly threaded scenarios. If we look at the geomean of the performance versus the prior gen and the 9950X, Intel is comparing the 9950X, You will see here that, let's see, the Intel Core 285 is a plus 5% in Geekbench for single thread. This is one thread here for single thread. That is a 5% above the 14900K. The 14900K is a line. And they are saying that that is under the 9950X, which is 8% faster than the 14900K there. If we look at this one, I've never run that one before, that specific test. That is 6% above the 14900K for the new 285K. And then 2% is the 9950X. So the 285K is doing better in that benchmark. We also see in Cinebench, this is single thread, 8% faster on the 285K versus the 14900K, which is faster, they are saying, than the 9950X at 2% above a 14900K. And then 3D Mark CPU profile single thread, 11% here over the 14900K, and then 3%, that's faster than 3% of the 9950X. So a little bit hard to read that chart. It's kind of confusing because their baseline is the 14900K, and then everything is compared to that baseline instead of putting the 14900K as a bar and whatever. We, of course, will run these tests and find out for ourselves, but I just want to go through the first-party benchmarks so you can see what they are saying and what the expectations are before our testing. Now we're going to look at multi-core performance. So 15% faster is the GeoMean versus the prior gen, and 13% faster versus the competition. But if we look at this, let's see, we got Geekbench here. So again, 14900K here, 285K, 11% faster in Geekbench, which they are saying faster than the 9950X, which with more threads. Remember, 285K has 24 threads, 9950X has 32 threads. So they are saying that their 24 thread part is faster than a 32 thread part in, well, pretty much all of these multi-core tests here. This one, Cinebench 3D Mark CPU profile max threads up to 19%, 18, 14. And they're saying the 9950X is actually a little bit slower than the 14900K in this test, but it is faster in all the others. But the 285K exceeds beyond the 9950X in all of these, even though it's a 24. Of course, these are first-party benchmarks, and they are going to pick benchmarks that favor them. I mean, who wouldn't? So we will have to run our own tests and run many applications and see how that really turns out. But you can see here that for single core and multi-thread compared to the 14900K, they're actually saying that it is a bit faster. And the important part here is, again, for the power that it's doing this at. This chart may be hard to understand at first, but the real important takeaway from this is at 125 watts, the Intel Core Ultra 9 285K is performing at the same performance that it takes the 14900K at 250 watts to deliver. So at 250 watts, the 14900K delivers a level of performance. The 285K, Intel is saying, can deliver that same level of performance, but only at 125 watts. So that's what they're saying. Same performance, half the power. That's what this graph is trying to tell you. So energy efficiency, leadership CPU core performance, 90% more multi-thread performance, 58% lower package power, same performance at half the power. Now for gaming, this is going to be a little bit different. So when we were looking at application performance, we were seeing an advantage across the board of the 285 versus the 14900K. Across the board in single or multi-thread, 285K was faster in everything. There was nothing that it was at parity or slower with. That's not the same for gaming performance. In gaming performance, Intel is saying that the 285K will have parity. That's right, parity with the previous generation 14900K in gaming performance. So the important thing that they are showing here is that yes, it's at parity, but it's at a much lower power with that parity. And that's what they're showing, except for a few games where that's actually not as fast, like Far Cry 6, which is real interesting, in fact. So here's the 14900K is, again, this white bar here going all the way across. And all of this is the 285K. And in Far Cry 6, Final Fantasy Dawn Trail, F124, Red Dead Redemption 2 even, negative performance. So that means that the 285 performs slower in these games than the 14900K. But in most of their games, it's at parity or above. So we see parity here, 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 here. We see 4% higher in Warhammer, 6% higher in Age of Mythology, 11% higher in Civ, and then F123, interestingly, is 15% higher, even though F124 was lower. Don't know what happened between the games there, but that's interesting. So the point here is that even though these are at parity with performance or close thereof, the system power, and keep in mind this is system power, this is not CPU package power. Total system power is down 58 watts, down 34 watts, so it's not huge. However, it's huge in these games, two games, 165 watt, 136. So what do I take away from this graph? The first thing I take away is it's extremely game dependent. Some games will be slower than the 14900K, some games will be parity, and some games will be faster. So it's going to depend on the game and how many you test. Number two, the level of power savings is also going to vary all the way from a small 30 watts, which isn't a lot on a desktop, all the way up to 165 watts. A huge variable of power, but that's going to be dependent on the game you're testing. And that's going to be the hard part for reviewers and everybody to look at is, in order to really get a feel for the power savings and the performance, you are literally going to have to do a 40 game roundup. I mean, there's just no other way, because if you do 5 games, it could be anything. It could be, it just not going to be enough because it varies so much and there's so much variable. So if you play a certain type of game, it may perform the same, worse, or better on the 285K at maybe a small power savings or a huge one. It just depends. They did show off some demos here in the presentation, and I'm sure everybody has probably seen this slide by now. And the point here is, again, an 80 watt system power savings at roughly the same FPS, actually a little bit lower on the 285K, but we can call that close enough to be parity. But the point is, they're doing that close to performance at an 80 watt power savings. So that's going to be interesting, but again, depends on the game. Depends on the game. If we look at what Intel has shown us here, we see a 79 watt total system power savings in Assassin's Creed Mirage. Call of Duty Modern Warfare 3 has 54 watt savings. F124 is 57 watt. Total War Pharaoh is 58 watt. Age of Mythology Retold is negative 136. Black Myth Wukong is negative 34. Warhammer Space Marines 2, 165. So we got some outliers there that are huge. But if you look at this, the outliers are the big ones. Mostly it's between 30 to 60 or 70 watts, right? That's where the average is. So I would say your outlier might be in the 100 plus watts, and maybe it's more like 30 to 50 watts. But we're just going to have to test and find out. And this was versus, or the baseline was the 14900K here is what they are comparing it to. So the GO mean of all that was 73 watts. Now, with this power savings also comes cooler temperatures. Arrow Lake should run cooler, and Intel is saying averaging 13 degrees Celsius cooler, package temp versus Raptor Lake R. So we've got, and again, that's going to depend on the game. They're not testing application temperatures here. Note, this is specifically game temperatures or temperatures while gaming. So if you do a full core multi-core, a full load multi-core application, like let's say Cinebench, you know, for the heck of it, the temperature difference you see there versus the game is going to be much different. So I'm really curious what is that going to be, because a game is not hitting all of the cores as hard as, say, running, you know, a Blender render or something like that. So I'm curious to see what the actual temperature and power savings are when doing that, and how that compares to games, because it's going to be different between both. So what are we really going to see? I can't wait to test it because I am curious myself. But we can see here on various games, 10C in Final Fantasy, 15C in F124, got 10, 15, 16, 13, 12, 17. So between 10 and 17 degrees cooler than the 14900K. So that's quite nice. I like to see cooler temperatures. That works for me. All right, so this is now versus the competition. So that other slide was versus the 14900K. Now we've got the 9950X as the baseline. So the brand new Zen 5 Ryzen 9 9950X. Now on this one, we're seeing kind of what we saw between the 14900K. There are some games where the 285K is slower. Cyberpunk, Red Dead Redemption, Final Fantasy, F124, F123 now here. Remember, it was higher before. That's real interesting. Oh yeah, that's what I forgot to mention in the last slide and this one. Intel APO is enabled, and that could be what's throwing off some of these results. Intel APO is enabled in all of Intel's testing on these slides. Very important to know that. It's enabled, it's turned on. APO is their special sauce software that better manages threads or thread allocation of the game and the P cores and E cores, mainly the E cores, but how it divides the threads and all that kind of thing. You can get much better performance with APO enabled in games that are that have that advantage, but it has to be supported specifically from Intel, and it has to be in the software of that game to support that. So not the game software, it has to be in the APO driver. So I guess it's the one with the stars that support APO. So F124 and 23 doesn't, so I guess that wasn't a factor. But yeah, real interesting. So just keep an eye on that. We'll talk a little bit more about APO at the end here. But anyway, some games are slower than the 9950X. Some are parity or close to parity, and then there are a few that are faster. But notice that's just a few. The majority is at parity or below. Now that is, of course, against the 9950X. What is that going to be against the 7800X 3D, the 7950X 3D? We'll have to test that. They don't have those benchmarks here to show us today. We will obviously have to test that. So looking forward to testing all of that. So Intel goes on to say, oh, they do have the 7950X 3D, not the 7800X 3D though. So versus the 7950X 3D, interestingly, they're showing that it is all the way up to 21% slower in Cyberpunk, 13% slower in Far Cry 6, parity in a couple of games, but in Civilization, 15% faster in the 285K, so that's real interesting. Now in content creation, this is again versus the 7950X 3D. Now, you wouldn't necessarily go toward the 7950X 3D if your focus is content creation. You would probably just do the 7950X without the X3D bar, so you can get higher frequencies on that. But they are showing here parity in Puget Bench, 5% faster in Blender, 18% faster in Geekbench, 21% faster Cinebench, and 30% faster in Pavre. So that's interesting, but I don't think the 7950X is the CPU you would really compare that with. If you're after content creation, then you're after the 7950X. But of course, we're going to test them all anyway, so we'll find out. Now, Perf per watt delivers awesome scaling for efficient gaming. So at PL1 125 watts, PL1 175 watts, and PL1 250 watts, it's consistent performance when tuned for compact gaming PCs. So across all of the PL1 or power states, this is just 7 titles represented, but you get that on par performance. And what they're showing here is that even all the way down to 125 watts, you're still getting that on par performance with the 14900K. I think this is versus a 14900K. I could be wrong about which CPU they're comparing this to, but they're saying that maybe this is actually versus the 285K. They're saying that as you lower power from 250 watts to 175 to 125, the performance in your game stays the same. So they are able to achieve a higher performance at lower powers, pretty much. All right, and as we already discussed, lower power, lower temperature, maybe on par gaming performance versus the 14900K. Now, of course, there's going to be a lot here about AI, and I'm not going to spend a ton of time on this because it's something that we're probably not going to test even in our initial review. We're going to focus on application performance and gaming performance. But here you've got faster render times and hardware support for professional codecs. So we have different codecs being represented here in the performance, and they are comparing against the 9950X. This is 285K against the 9950X, and we're seeing that it's It depends on the application, but mostly faster, if not on par. Some places where it's a little bit slower, but it's going to be highly dependent on the app. Some apps do take better advantage of the CPUs or take a different advantage of the CPUs, like Photoshop or, Premiere. So depending on how it's using it and what kind of workloads you're doing in that application, because something you're doing in Premiere or Photoshop, depending on that workload can even be very different. So those different workloads could react differently on Intel or AMD. AI feature growth. I mean, there's going to be a lot about AI and the NPU. Geekbench AI is a new program, and I think I do want to test this one in our review as well to have those numbers in there, and we'll test that and see. But up to 2 times the performance of Raptor Lake R plus NPU 3 for new performance per watt opportunities. Again, it's there for people who don't have a discrete GPU, because if you have a discrete GPU and a desktop PC, that's what you're primarily going to use if you're doing, huge AI workloads. But it's there if you don't have that, and I think that's the good reason for it otherwise, if you're going to use it. But keep in mind, it takes up die space. So, is that something that is going to be extremely beneficial in the future? We don't know. We don't know. I have not yet seen a great case for it, but maybe there will be that killer thing that everybody wants, and in that case, Intel is seeding the future with that support by having the NPU in this new generation. Procyon also got some performance things there. Intel AI optimization fuels winning performance. Sure, they're saying everything's faster than the 9950X. Sure, I mean, that's their first party results. I don't know. There's what they say. Cephable is another demo they showed where you can do some interesting things with AI. Balanced AI performance, 50% faster creator AI, Intel's first desktop AI PC. So that's how this is being sold. It is a desktop AI PC because it's got the NPU in it. Yes, it's a 13 top NPU, but it's there. Of course, you could also do those things on the GPU or compute tile as well, just with less performance. So now let's talk about the socket and chipset. As I mentioned, this is going to be on a brand new socket, LGA 1851, whereas previously it was LGA 1700. So the big thing here that I think enthusiasts are going to cling on to with this is the amount of PCIe lanes you're getting. You're getting like double the PCIe lanes with this generation than you were in the previous generation. And that's going to give you more flexibility on the desktop for creating or having more I/O options. So this is actually pretty exciting. 48 total PCIe lanes. 20 of those are PCIe 5.0 lanes. The chipset, and those are from the CPU, the chipset is the 800 series chipset, and you will see the Z890 coming out first. There may be other chipsets below that in the future, but right now all that's announced is the Z890, which is the highest end chipset. That provides 24 PCIe 4.0 lanes coming from the chipset. So you have 20 PCIe 5.0 lanes coming from the CPU, and then 24 PCIe 4.0 lanes coming from the chipset. You have up to 10 USB 3.2 in various configurations here, a 5x20G option, 10x10G, 10x5G. So different variations of USB, 14 USB 2.0, and 8 SATA 3.0. So different configurations. You are also getting some integrated support for some very good things here. You get Thunderbolt 4 integrated support. You get Intel's killer Wi-Fi 6E support, Bluetooth 5.3, and gigabit LAN. Now, the discrete options, that comes from the manufacturer. So a motherboard manufacturer can optionally put additional things on there like Thunderbolt 5 or Wi-Fi 7, Bluetooth 5.0, 2.5 gigabit Ethernet. So those are things that can be added discreetly, but from the native support, you're getting Thunderbolt 4, Wi-Fi 6E, Bluetooth 5.3, and gigabit Ethernet. So also, Intel is talking about overclocking and the ability to push these CPUs even further. Apparently, there might be some headroom on those E-cores. That could be interesting. more tighter and finer control of granular clock speeds, dual base clock for the SoC and the compute tiles. You can bypass the DLVR, which is interesting. Also, a low temperature overvolting. As the temperature decreases, you can raise the voltage. That might not be too safe, but you can do it. P and E core overclocking, memory overclocking, of course, with XMP as well. And we're going to talk about memory support because that's kind of interesting and fun. It supports the Intel Extreme Tuning utility in software. So there's going to be a lot of flexibility for enthusiasts here. And I think that's exciting. Not a whole lot of talk about undervolting, but for those that are into undervolting, let's see how that turns out. But with the Intel Extreme Tuning utility, perhaps there'll be a lot of flexibility there with that. So that could be very fun. Let's talk about the memory though, because that is much more exciting. So as we said, up to DDR5 6400, but keep in mind that's one DPC, not two DPC. In 2 DPC mode, it's 5600. So just keep that in mind. But it can be up to 6400 for the like JEDEC speed that you run at. What you're going to be seeing a lot of with this generation is talk of new memory types, specifically the QDIMM or clock unbuffered DIMM. This is going to be quite popular and quite a new upcoming type of DIMM module for this series and for anything. And that's going to help allow higher stable clock frequencies. It's got a clock on it that literally tightens up the frequencies and everything so that it can maintain higher frequencies. This is what's going to get you above 8,000. This is going to get you to the 9,000, the 10,000. These CU DIMMs, you're going to be hearing a lot about it. And we'll talk more about it in our review. We might even have some CU DIMMs coming in, which could be very exciting to test memory overclocking with. But this could be an enthusiast kind of thing that we think a lot of enthusiasts might actually have a lot of fun with and could bring a lot of fun back to pushing memory frequencies really high. These CU DIMMs are something that I'm actually pretty excited about to see, because the ability to maintain higher frequencies on memory with either with AMD or Intel has been kind of difficult. These new DIMMs might make it a little easier. And with all the improvements, we've got improvements in the memory controller here with the 200S series. Memory overclocking could be a very fun thing to get into. Could. So we'll see how all that turns out, but that's the memory for this generation. We went over all that. That's a summary. Here's another summary. Flagship gaming FPS. And by that, Intel is using a 31 game sample here. So that's pretty impressive for the amount of games they're using. And they're saying that's compared to the 9950X. 13% faster CPU compute performance, lower temperatures, lower power, 36 platform tops, but remember that's all the tiles combined on that one. Partnerships with different partners here is very strong with Intel, and that is being maintained. A little hint at something coming in the future, first quarter of 2025, is the Intel Core Ultra H and HX series for enthusiast mobile performance at lower power. So that's something to keep in mind coming next year. That's it. That is the entire slide deck for the Intel Core Ultra Processors 200S series. So let's talk a little bit about this. The big talk is going to be the parity performance with Raptor Lake, but yet at lower power. Is that going to be enough? You have to consider that they got rid of hyperthreading, they've lowered the frequency, and so they are relying on the new P-Core and E-Core architecture. They're relying on that IPC increase and other improvements like the cache and the bandwidth and the wider allocation and all of that. They're relying on those things to have the chip meet parity with like lower power and lower clock speed. That's what you're seeing out of this. So without hyperthreading, SMT gone, now you have just however many cores you have. That could be a good thing though, so keep this in mind. Removing hyperthreading on Lunar Lake has actually proven to be very good for Lunar Lake. It's actually turned out really well for Lunar Lake in power savings. Like that's part of its power savings message, and that's actually been okay. If Intel can achieve the better performance without hyperthreading and save power, Maybe it's not needed after all. Maybe we do need this paradigm shift away from SMT on the desktop. Not for server, but for desktop. Maybe it's finally time to move beyond that and get rid of it. It's always caused problems in the future. There have been a lot of people doing specific enthusiast tweaks that disable hyperthreading because they think they're going to get better gaming performance. That's been a huge thing that people have done. Or turning off E-cores, or all these things to improve performance for gaming. But hyperthread, it always comes back to hyperthreading, that it's kind of been a nightmare in Windows because of the way Windows manages hyperthreading, or manages threads, period, across different cores on CPUs. So if you just remove that, maybe you take away a huge burden on Windows itself managing things on the CPU. I don't know. It's just a thought. So I'm not too hurt by it. I remember when hyperthreading first came out. That's right. I remember when it came out and was the huge talk. And back then it mattered because you didn't have multi-core. You only had 1 or 2 cores and you needed to have more threads. But we're at a point now where we do have a lot of threads. We do have a lot of cores. So maybe that's just a thing we need to move beyond. I don't know. It's an interesting talking point. When we look at the power savings that Intel is getting overall, that has been needed. Raptor Lake and Raptor Lake Refresh is a lesson in what happens with when you chase performance and you sacrifice power. It's a lesson in that. Perhaps this is a turning of the corner for Intel, a turning of the corner into the future of the next generation and the next generation. We make these changes now, we get rid of some of these things, we refine things, and this prepares us for the future. Perhaps that's what we're looking at. It is, however, a little disappointing just on its own that from one generation to the next, you will not necessarily be seeing a real world performance advantage. You know, something that's actually going to end up calculated in your game, your gaming performance, or your application performance. Sure, that's a little disappointing, and I guess that just continues the 2024 year of disappointment that we are accelerating through at the moment. So it's interesting, but I think we just really need to get more data. We need to test games, we need to test applications, and we just really need to see where it all falls. Keep in mind that this first round of testing and reviews will not be our last. We plan to do much more coverage and follow-ups. So what you see on review day will just be a snippet and cover a small amount of what is possible to cover with these new CPUs. We can only do so much in such a limited time. But as time goes on, we will still have the CPUs and be able to do more with them, have more articles, test more scenarios and different things, and keep evolving the conclusion. It's going to be an evolving conclusion. But let's talk about gaming performance. This is another scenario where it's really going to depend, well, just performance in general for application or gaming. It's going to depend what you test and how much you test. Because if you do a small subset of applications or games, you may end up with one result versus a different result if you did a large subset or a different set of applications or games. One person who tests, you know, this set of 5 games here, and another person who tests this other set of 5 games could come to different conclusion because those 5 games tell you subpar performance, whereas these 5 games could tell you on par performance or better performance. So if you choose different things, you're going to get different results. And that's why we really feel that this is another review. These reviews we're going to be doing here on these CPUs that you're going to see from everybody on the internet and written or in YouTube. All of these reviews may have different conclusions. We're going to have a varied conclusion kind of review like we did with the Zen 5. This will be another Zen 5 conclusion type of ordeal where people will come to different conclusions based on what they tested. If they tested this subset of thing, it's going to have a different result and they'll come to a different conclusion. Somebody else will test a different set of things and they will come to a different conclusion. Somebody who focuses only on games is going to have a different conclusion than somebody who focuses only on applications. So what you test and how much you test will change your conclusion and how you conclude these CPUs. I want everyone to keep that in mind because this is going to be, in my opinion, similar to the Zen 5 launch, where every reviewer is going to have different conclusions because of what they tested. Also, how much they tested. If you do 5 games, you're probably going to get a different result than somebody who tested 30 games. And that's just the way it is. So keep in mind, when you look at people's reviews coming up for these CPUs, look at their test setup and how they are setting up their test system. Look for what applications they are using, which ones specifically and how many, and then what games they are testing and how many. And as you compare different reviews across the internet, compare those games to those games. You know, look at all the different games all together. It's going to be varied and it's going to be a mix, but that I think is what makes the reviewing industry very beautiful, because you have such variety and you can go through and read everybody's review and make an informed decision. We will do the best we can for the launch, and we will have more things to follow after that. Should be some quite exciting things to test here. It's exciting for the enthusiast. It's exciting for the gamer. There's all different kinds of things we can test, and I am quite looking forward to it. And I am quite excited just by the amount of new hardware we get to test, and you know, it's going to be fun. It's going to be fun at heart. And so don't take anything too seriously. Just make sure you read and take in all the results from all around. APO will be another thing. I did want to touch on that a little bit. From what I have been reading or hearing, APO may now be enabled in the BIOS by default, and also Windows will manage APO, and you do not have to download a special software for it. If that's the case, and if it's the default operation that's just always turned on Intel CPUs, then that's fine to test that way, because that's the default operation. It's just like how now rebar is enabled by default on motherboards, and it did not used to be, but now you install any new motherboard, rebar is on by default. There are other things that are just on by default now, like VBS. That's been a big one, that security issue in Windows that could potentially slow down performance. Some people turn that off, but the default setting in Windows, when you just install Windows, it's on all the time. And so it's okay testing in these default scenarios. Also GPUs, because we test GPUs a lot. NVIDIA has a GPU feature in Windows that's turned on all the time. It's a driver management kind of feature that's enabled, and you install a driver or Windows and that's on all the time. That's just on by default. So there's things like this that are turned on by default now, either in motherboard BIOS or in Windows. And as long as you test all of your CPUs and all of your systems with that same default configuration and all the same way, then you're good. Just don't test anything different. Don't turn something off or something on one set of CPUs and something off or on a different set. Keep it all default and you're good. So APO will be an interesting thing to see how everybody handles that. But in my opinion, we're going to take Windows 11 24 H2, which is now out, thank goodness. We're going to take that. We're going to run it we're going to install it as any user would at default. We're going to run it at default. We're not going to change anything. I'm going to turn off any starting programs, but other than that, we're just run it at default, and we're going to run the motherboard BIOSes at default and go forward. And that's going to be the same on every CPU. And we're going to use the same hardware, as much of the same hardware as we can between each CPU. So keep all that in mind. Also, let's talk about the power, PL1, PL2, and the power profile for Intel. We have been doing a lot of testing. In fact, we've got a YouTube video and a written article enabling the new microcode on the new on Raptor Lake. And we looked at the performance differences by enabling that microcode. So you want to check that video out, and also our written article. So we looked into that. We also enabled in those reviews both the extreme and performance profile. We specifically asked Intel, what will the Intel Core Ultra Processor 200 series be running at? And we were told the performance profile, not extreme, but the performance profile. So therefore, that's a little different than Raptor Lake, because on our Raptor Lake motherboard, it runs in the extreme profile by default. So that's interesting, and that's going to be another hurdle to cross as well. But Intel told us for 200S series, it's performance. We will see what that actually ends up being when we get the CPU and the motherboard and install it. It'll be interesting to see what profile is actually the default. And I don't know, maybe we just test both anyway. But that's also going to be something to look for in people's reviews. You want to see what profile in the BIOS they tested in, the extreme or the performance. Was PL1 and PL2 locked at 250, or was it running at the unlocked? Those are going to be important things to look at. But again, we're going to use the default BIOS settings, whatever they are. And if we have time, may run 2 different profiles just to have both in there. Or maybe that's a separate article and we do a comparison to see what the difference in performance is between extreme performance. It's going to be something new and interesting to learn as we move forward. This is all basically me just spitballing with you all and being real and telling you what some of the hurdles are that us reviewers have to go through, and to let you know what our process is. Our process, I want to be very transparent about our process. Our process is always to test at defaults, install Windows fresh, don't change a thing, but we do that for each platform. Fresh installation of Windows, don't change it. Default BIOS settings, don't change it. Latest BIOS, but default settings, optimize default settings, leave it at that. Except, of course, we do enable XMP or Expo. So, we'll run at the 6000 for the AM5, and we'll run at something for the Intel Core Ultra Processor 200S series. I guess we have options on that. 6400 is the JDAC. But 8,000 may be a common thing as well we see here. So there's going to be different areas there to test in as well. So a lot to look forward to. It's very exciting. You can tell how excited I am. I love new stuff like this. New hardware is fun for us to get in. So I cannot wait to get testing. I've got about 11 CPUs to test between now and launch day, and that's going to be fun, with several different motherboards and RAM and several installations of Windows and games and apps. So a whole lot of fun. Honestly, truly, it's fun. I'm an enthusiast. I enjoy it, and we're going to try to do the best we can to bring you all the information we can, but there will be more to follow after that as well. So there you go, everyone. Intel Core Ultra processors, October 24th. That's when these will be on sale. Again, the prices, $589 USD for 285K, $394 for the 265K, $309 for the 245K. At $589, that is cheaper than the 9950X, so that's a cheaper price than the flagship Zen 5. However, for the 265K and 245K, that is a higher price than the equivalent 9700X and 9600X Zen 5. However, as I mentioned at the top, street pricing is what matters the most. So while this is MSRP or suggested retail price, the actual street price will be different because right now the AMD Zen 5 CPUs are cheaper than the MSRP. In fact, they can be had cheaper on Amazon or Newegg. So that matters the most. And I think that's the price that we will talk about the most, because that's what you can actually purchase them at. So that's going to be very good competition price-wise for the 200S series. It'll be real interesting to compare those prices and the performance that we get out of that. I'm looking forward to it. It's going to be real interesting. But there's the prices, and I hope you all got a little bit out of this today. I know this was kind of long-winded. I said I'd go through it as fast as possible, and I did not. So I completely failed. Ship A, I failed. So there you go. Anyway, everyone, this has been your host, Brent Justice, for thefpsreview.com. Thank you so much for spending your time with me on a very late night as I record this. Thank you so much. I hope you have a very, very blessed day. Thank you so much for watching, and stay tuned for the next one.